Hey guys, welcome back to our YouTube channel. Today we are going to solve the problem known as sort colors. Okay, so this problem statement says that assume we have three colored objects, that is red, white, and blue, and we have to sort them so that objects of the same color are adjacent. Basically, all the red objects, all the white objects, and all the blue objects should be together, right? And to indicate the object, we are using integers, that is 0, 1, and 2, right? Basically, to indicate the color. So basically, our problem becomes we are having an array and it contains 0, 1, and 2, and we have to sort that array, right? That is our problem. Okay, so let's say we have this array 2, 0, 2, 1, 1, 0. So what we have done is 0, 0 first, then 1, 1, and then 2, 2, right? So this is the problem statement. So before we start coding, let's think of the possible solutions we can have, and then we will come back again and solve it. So we are given an array 202110, right? And we have to sort this array, correct? Now you will say, right, that this is just sorting, right? Why we are thinking much? And we can simply do the sorting algorithm. We can use any of our sorting algorithm and sort this array, right? So that will be the most obvious solution, and it will come, at first place in our mind, right? So we can do that, right? No issues. We can just sort this with using any of the sorting algorithm that you know, and you will get the correct answer, right? And this is our brute force solution, right? And if we think the time complexity of any sorting algorithm in ideal case, it will be of n log n, right? Where this n, I am assuming the length of the array. Yeah, yes. So n is my length of the array, right? And n log n will make by time complexity, right? And considering space complexity, it will also be of n, right? But, right, to sort an array with 0, 1, and 2, are we using really need to use this much time and this much space, right? There must be a better way, right, to achieve this. Like, just why to waste this much space and time, right? To if we have to just sort array with only just three kind of integers, right? So to optimize it further, let's think, you know, a better solution for it, right? So this is the brute force one, that is clear, right? Just use any sorting algorithm and we are done, right? But now, as we see, we have only three types of integers, right? That is 2, that is 0, and that is 1, right? So why do we need to sort this by using our sorting algorithm, right? We can just do, we can take, count of 0, three variables we can maintain. One is I, right? Another one is J, right? And another one is K, correct? And what we can do is, first we can loop through this array and count the number of zeros, right? And then we can loop through this array and count the number of ones. Similarly, we can count the number of twos, right? Now we have the count of all the three integers, right? In 0, 1, and 2 with I, J, and K, right? So what we know now is, first of all, we have to place the zeros, correct? That is, we need 0. So basically, what we can do is we can iterate from 0 to I, right? I is my count of zeros, and place each element as 0. Correct, right? Basically, it should be I minus 1, right? Because till I there is zeros, the count of 0, and we are starting from the 0 indexing. So I minus 1, we have to run our loop, right? Now, next thing what we can do is we can start from I, right? And we can go till j minus 1, right? And place all the elements as 1, correct? After that, what we can do is we can start from I plus j, right? We can start from I plus j and we'll go till the k, right? And we can place all the elements as 2, right? So in this approach, basically we are counting the individual array, 0, 1, and 2. We are counting the individual element occurrences and then looping the array. And as per the occurrences of each element, we are just, you know, placing that element in that manner, right? So, as we are using a for loop to count the occurrences of the three elements, so it would be of n, and then we are placing also all the zeros in these, after counting and 1 and 2. So it would become of 2n, right? The time complexity, as we are using two for loops and we are not using any extra space. So the space complexity will be constant and it will be of 1, right? So this is the better approach, right? And most of you will think that, this is the best one. We are solving it in of 2n, sorry, and space is also constant. And seeing this question, we can't think of any other approach, right? But the next approach will blow your mind. Basically, it is seriously a very cool approach that we are going to use to solve this problem. So stay tuned and we will see the next approach in just a moment now. So till now we have thought of a better approach from the brute force one, that is counting all the occurrences of each of the elements and then placing as per the order, that is first 0, then 1, and then 2, right? Now this new concept or the new algorithm to solve this problem is very famous algorithm and we call it as National Dutch Flag algorithm, right? So before we start this algorithm, first we, making dry runs and everything, let's think or let's see what this algorithm basically states, right? So it states or it assumes, if I say that, you know, let's say I have an array of 0 till n, where n is my length of the array, right? So it states or it assumes that we can partition an array in such a way that from 0 till, let's say this, I'm indicating this with L minus 1, right? All the zeros will reside, that is in my first portion, or I can make it, more better for you guys. That is in my first portion, all the zeros will be there, right? Till L minus 1, right? After that, it says from L to mid minus 1, that is, let's say my M variable, M minus 1, all the ones will be there. That is 1, 1, 1, 1, and let's say 1. Okay, and it says from M to my high, right? We don't know. It can be, anything basically. Okay, It can be anything. Okay. And from high plus 1, okay, till my length of the array, that is n, right? I have only 2's. So this algorithm states this. Okay. So this is a kind of a rule or the assumption of the algorithm. Let me reiterate. That is, from 0 till your low minus 1, we have all the zeros. Basically, these all are the indexes, okay, from 0 to L minus 1. And then from L to your M minus 1, basically mid minus 1, is your all ones. Okay. And then there is a portion in an array, it says from mid to the high, where anything is possible, 0, 1, or 2. Basically, that portion or region is unsorted. Okay. And then from high plus 1 till the end of the array, this region is of only 2's. Okay. So this algorithm dividing our array or partitioning our array into 4 halves. Okay. And in this 4 partition, first partition says all zeros, second partition is all ones, and third partition is, not sure. It can be any numbers. And in the last partition, it says all twos. Okay. So what we have to do now is, or let's now think. Okay, so what can be the possible situations? Okay, so let's say, here in this 0, 1 and 2 lies. Okay, because anything is possible, right? So let me assume here in this region 0, 1 and 2 lies. Okay, so if we start, this m variable, what are the possible cases? Okay, first one is a of m is equal to 0, right? And another case can be this a of m equal to 1, right? And the last and final case would be a of m would be 2, right? Only these are the three possible cases, right? Correct? 0, 1 and 2. So now let's think. Let's say I have 0, right? This m is having a 0, right? And if I need to sort this, what I can do, what is the best possible case for the 0? Like as I stated, that 0 should be in the start, right? So basically I need to move this 0 in the start, right? And that means I can simply swap my this 0 with this 1, right? Because till L minus 1, all zeros. And I can, append one more 0 here in the end, right? And, and this 1 I can shift here, right? This I can easily do, correct? So let's do this. In case if it is 0, I need to move it in the front. Let's say I made 1 0 here, and now this element is becoming 1, right? So in case of 0, I swap, right? I swap, and what I swap was L and M, right? So after swapping, what happened? This 0 is here, right? That means my L position is now pointing to a 0, right? But our algorithm says L minus 1 is 0. That means this L, I can move one more step and it becomes, I can do L plus plus. right? Similarly, my m is 1, right? And I know till mid minus m minus 1 are sorted, basically all ones, and n is also a 1, right? So I can do is m plus plus, correct? Fair enough, right? So now this m is moving here. I moved it, right? Now this is not here, correct? Now what if I get a 1, right? If I get a 1, basically my a of m is 1, it means it seems fine, right? Till middle this L to m minus 1, I am saying once, and if my m is also a 1, that means I have to do nothing. I can simply increase my m because my m is also a 1. That means I don't need to do anything. This is automatically sorted, right? So I can move my m from this place now to the next place, right? Now I am getting a 2, right? So my a of m is 2. Now what is the best place for the 2, right? The best place for the 2, we know it should be in the end, right? That is from the h plus 1 to till the end. So what I can do is, if I just, you know, place this 2 in front, right, and swap whatever is there at the h. It can be any number, right? 0, 1, and 2. We don't know, right? But we know that at h it will be 2, right? So that means I can swap, right? We can easily, swap the, what to say, this m and the h, right? And now this h position will become 2 after swapping, right? That means I said earlier also that h plus 1 till n is sorted. Now h is also 2, right? That means I can say that till here is sorted. I can, you know, move my h backwards because till h plus 1 are now sorted. And as this m is now anything because we have swapped from a unknown area, right? We don't know what it can be. It can be anything. That means this m is still has to be sorted. So we will not move m, we will just move h by 1, right? And we can swap. So these are the all three possible conditions in this algorithm. Basically, when we encounter a 0, we can swap our low and mid and simply increment both of them, L and M. When it is 1, that is, it is already sorted this place. Basically, it is coming along with the M minus 1 area, and we can just simply move our M one step ahead, right? When it is 2, right, this means it is 2 and we can swap it to the end of the array. So basically we swap m and h. Now this we swap m and h, and a value of h we don't know. It can be anything, 0, 1, and 2, as h belongs to the unsorted area. Now the m value can be anything as you have swapped. So m can be anything. We are not sure of the place of m, so we can't move forward with m. So we just decrease the h, not haven't done anything with the m, right? So this is the intuition of this algorithm, right? Now let's do a dry run. Okay, so to do the dry run, what I can do is I can just, if I can, easily do this or not, no issues. What I can do is I can, you know, let's say have this array 2, 0, 2, 1, 1, and 0, right? So as per the algorithm, we can say, as I said, this mid to the high area is the unsorted one, and this is unsorted, we are assuming from the beginning. So my M is here and H can be here, right? And as we know, till low minus 1 is sorted, right? And we have nothing before that, so we can assume, we can assume that low is also there, right? Because we don't have any element before this, right? Now, let's start the algorithm. We encounter 2 first. So, in case of 2, what we need to do? We have to swap M and H, right? That is this 0 and this 2. We will swap, right? That means what I can do is I can place 2 here and I can place 0 here, right? Now, as I sort M and H, right, that means I can decrease my H. Now, H is pointing here, right? Now, again, let's see. My M is 0, right? When my M is 0, that means I can swap L and L and M are at same place. So I can simply move both, right? So my M is here now and L is also here. Correct? Fine. And now again I am having a 0. So again I can move my L and M, right? So I can move my L and M again. Now this L is there and this M is there. Correct. Now if you see the first two elements are 0 and the last is 2. Now again I am getting a 2. That means I need to swap M and H. So here it will be 1 and here it will become 2, right? And we will decrease H, right? Now my H is here. Now this is 1. When M is 1, I can simply move my 1, right? Move M by 1. So my M becomes here, right? And now as M and H are same, we can stop our algorithm, right? Now if you see, this is the 0, this is the 0, now this is the 1, 1, 2, 2, right? So if you see, our array is now sorted by using the Dutch flag algorithm. Okay, so I hope you have understood this algorithm. As you know, it takes time to understand this, and I will suggest you, to first try run this so that it will become, realistic to your mind, because this is not the algorithm which you can think while solving a problem in your interview, right? So you first have to understand this algorithm. And now we have understood all the approaches. And before we, go and test this in our code editor, let me talk about the time and space complexity. As I'm using 3 pointers and I'm iterating this array only once, so time complexity will be O of n, assuming n is my length of the array, and I'm using only 3 pointers, that is the constant space, so it will be O of 1. Okay. Now, this is the space and time complexity and is the most optimal solution we can have by using the Dutch flag algorithm. So, now let's go back to our code editor and start coding this algorithm. So now we are back to our code editor and let's start coding this up. So what we are given is an array nums, and in return we have to do nothing. We just have to modify this nums array. Correct? So what we know is from the algorithm that I need to have my three variables, right? Low, mid, and high. Correct? That I know. And while initializing, I know this low I can initialize to 0, mid is 0. Basically, mid and high are the unsorted regions, right? So from 0 till the, you know, length minus 1, we have the, unsorted region, right? So what we have to do is we have to loop through it until this mid is less than high, right? And we know what are the possible cases, right? Only possible cases are if we get a 0, right? Or if we get a 1, or if we get a 2, right? These are the only three possible cases that we have discussed, right? So we know when we get this, we need have to swap, right? If it is 0, what we can do is we can simply swap this. And what I meant by this is I need to swap my low and the mid, right? Basically, the swap function we will create later, okay? And after that, I need to increase my mid and low, correct? And if it is 1, I know I'd have to not do anything. I can just simply increase my mid. And if it is equal to 2, that means I need to swap my mid and high. And this time I know mid can be any number, so I will not touch mid now because this swapping is done from the unsorted area because high belongs to unsorted area. And if I swap mid and high, that means the mid will get now the unsorted part, basically an unknown number. And I can say my high is sorted, so I can decrease my high. Right. That's it. And now what I can do is I can, have this swap function where I can say that I have this nums, right? This nums, this I, and this j, right? So for swapping any array, we know that it's very simple process. Just I can use a temp variable, and inside that, I can store the number, and then for me, swapping will be easy. And after I am done with changing one number, I can place back temp value in that number, right? So this is my swapping. Now let's run this and see if we are able to solve this or not. Yes, both the cases are accepted, and let me submit this solution now and let's see. Yes, so our solution is accepted. So this is the solution for sorting an array with 0, 1s and 2, or we can say national Dutch flag algorithm. And if you guys have any doubts, please feel free to mention in the comments. I will help you out. And before you start coding this, I am specially mentioning that please try run this algorithm as much as you can because this is not an algorithm which you can, easy to understand in the first go, right? And if you have understood this solution and the algorithm, just mention understood in the comments so I can get to know how many of you have understood. And so that's it for this video now. We'll see you in the next one. Till then, bye bye. Take care.